Maybe I'm wrong, but we plug in 20.
We haven't differentiated this. The rate of change is P of x over x prime. We have not differentiated this. We don't have this function yet. I have to find the function in order to plug it in. I don't have the function yet. We only did the algebra. So I need to differentiate this, I need to differentiate this, I need to differentiate this, and write it here. Is that better, everyone?
Oh, yeah. So going 75 times
Negative 0.2. Let's
negative
write it. 75 times negative 0.2. Oh, I don't think that this is a good one. Sorry. So 75 times negative 0.2 x
minus 900 times.
Careful. We haven't discussed the power yet. I bring down the power, but I have to subtract one.
Yes.
So negative 1.2. Yes. Good. Now I bring down negative 1, so it's positive 900 times x to which power?
Minus 2.
Excellent. Now I bring down negative, so it's going to become positive 18 times 0.3 times x to which power? This was negative 0.3.
Minus 1.3.
That's it. Awesome. Let's clean it up a little bit and then plug in 20. Yes. Okay. So this is 150. So 15, negative 15, x to negative 1.2. This is just 900 x to negative 2. And this is what? 5.4 x to negative 1.3. So I multiply these two and I got this. This was 900 x to negative 2. And I multiply this and I think I'm correct. And this. Now I will find P of x over x prime when x is 20. We can just write parentheses 20, that's fine. So P of x over x prime at 20.
Can you go over how you got 5.4 again? Or that whole
3 times right this here? You mean from here? Oh. I swallowed x. So negative 18 times 0.3. 4 and 2, yeah. 3 times 1 is 3, 5. And there is point here, so I have 5.4.
What about all the stuff on the right, the 15 and the 900?
Negative 0.2 times 15, 2 times 75 is 150, and I have...
Are you just not doing that stuff right now?
So, say it again.
Are you not dealing with those numbers right now? You're just dealing with the 5.4?
No, so this is the final form. This is the final form of the function. And I have to plug in the function. I have to plug in 20. But I can do this by hand. I have to put this function in the graphing calculator.
Okay.
Was that okay? Was that the question?
I think so.
Okay. Just making sure I answered your question. So in y equals, clear?
Now question is the 900 the power of x minus 1 is the coefficient not come to down?
We did not use the quotient rule. Oh, you want to write this as 900 over x squared? Yes, you can. Yes, that's fine. You can write it as 900 over x squared. I'm sorry?
We don't have a coefficient multiplied by the 900. 0 point something, 0.2.
A quotient requires a function over another function. Here you have a number over x squared, and this is already differentiated. You don't need to differentiate it again.
Okay.
If you differentiate it again, you're going to get the second derivative, not the first derivative. We already differentiated it when we from here we differentiated it already. And we did not need to use the quotient rule because the quotient rule requires the numerator to be a function. but this numerator is a constant, it's not a function. Now, if it has x, I have to use the quotient rule, but it doesn't. So now in the graphing calculator, I will punch in. Oh, I'm sorry, I lost you for a second. Okay, so in y equals, I have negative 15 and multiply by x power. I always like parentheses for these powers because also I don't know what type of calculator you have. And then come down and then plus 900 and times x. And again, the power is negative 2. And come down from there and then plus 5.4 and times x and the power and in parentheses negative 1.3 and close. I like to see the function. You can say, do you really need to? You're only plugging in one number. No, I don't, but it's easier for me to see the function, make sure I entered it correctly. So it's 1.95. 1.95. Okay, so now let's establish the measurement unit. What do you think? The measurement unit for a rate of change.
How did you see all the values after you put it in the y equals button?
Let me share again. You're saying, how did we put it in, or?
How did you get it where it showed like, yeah, that screen? What was that?
Second and table.
Oh, okay, thank you.
Sure, and you plug in 20. Okay, the measurement unit for this. Dollars per unit. Two measurement units, profit per unit, because that's the unit, x is the unit, and this is dollars. Profit, the average rate of change. So what does this mean? When 20 units are produced, the rate of change of the average profit is $1.95, $1.95 per unit.